In this video, we have a polynomial function, f of x equals 3x to the fourth plus 17x to the third plus 26x squared plus 2x plus 20. We are told that x equals negative 3 minus I is a 0, and we need to find all of the zeros for the function and then find all of the intercepts of the function. Now, one of the things we need to remember is that when you have a polynomial function with all real coefficients and a constant that's real like this, if you have a zero that's complex, then we automatically know that its complex conjugate, in this case negative 3 plus I, we know that this is also a 0. So we have a polynomial function of degree 4. You are given one 0. You know that since it's complex, its conjugate is another 0. So of these 4 zeros, we already know 2 of them. And if we can do synthetic division with each of those one at a time, we'll go from a degree 4 to degree 3 to degree 2, which means we'll be able to end up with something that's quadratic. And after that, everything is super easy for us. All right, so let's go ahead and do that. Let's go ahead and get that synthetic division going. Now, I'm going to let you know that this first part of synthetic division is going to be kind of messy. So we just have to take our time and be careful about this. Now, this is going to be an extra big one because we have a k value here. We have a k value that is negative 3 minus I, which means in this process of synthetic division, every step I'm going to be multiplying times negative 3 minus I. And when I do that, it's going to be kind of complicated. It's going to have two pieces. It's going to have the real and the imaginary part. So make sure that you space things out appropriately so that everything can fit. All right, so we have x to the fourth, and we're going to go down by degree every step along the way until we get to the constant term. So we have 3, we have positive 17, positive 26x squared, positive 2x, and positive 20. Now, what I like to do is I like to create just a little bit of separation here because things are going to get complicated, and it just helps me with the organization, and it helps me avoid having part of the problem bleed into another part. So, first things first, like we always do, is that we bring down that lead coefficient. So we just bring down the 3 like that. And then we multiply times the k value. Now this first part's pretty simple. We're going to be doing 3 times negative 3, so that's negative 9. And then 3 times negative I, so we get negative 3I. And I hope you can see why I've got this these extra wide columns, because I need that to accommodate the two pieces for this complex number. So 17 minus 9 is 8, and then minus 3i, bring that down. And then we need to multiply this complex number times that complex number. Now, if you feel like you don't want to try to cram everything in, excuse me, you can just grab a piece of scratch paper. Got it. And we can just kind of scratch things out. So what we need to do is that we need to work on doing this product here that's negative 3 minus I times 8 minus 3I. Okay? So just taking a piece of paper off to the side so that we can multiply this out. So FOIL gives you negative 24. Negative 3 times negative 3i is plus 9i. On the inside is minus 8i. And the last piece, negative times negative, is positive 3i squared, but as we've seen so many times, when you have I squared, that just changes the sign, and it makes this guy negative 3. So when I combine like terms, we have negative 27 plus I. Alright, and so now that's what goes up here. So negative 27 plus I. Combine these guys, we have negative 1 plus I, and then we have to do the same thing. Okay, we have to multiply negative 1 plus I times negative 3 minus I. So again, I'm going to use my little scratch piece of paper over here. And we need to do negative 3 minus I times negative 1 plus I. And again, you're just going to FOIL this. So distribute the negative 3, we get positive 3 minus 3I. Distribute the negative I, that's positive 1I. Negative I times positive I is negative I squared. And a minus I squared just becomes, becomes plus 1. So when I combine everything here, I get 4 for the real stuff. Negative 3I plus I is minus 2I. So 4 minus 2I goes up here. And again, with synthetic division, we combine these guys. 6 minus 2I. And then we have one last step where we're going to have to multiply 6 minus 2I times the negative 3 minus I. Now, I already know what the answer should be. And the reason I know what it should be is because of what we were given. We were given that this value is going to give us a 0 for this function, which means my remainder over here is supposed to be 0. If it's not, then we've done something wrong. So I know that when I multiply this, I better get negative 20 so that I can get a 0. Well, let's see if that's true. FOIL, negative 3 times 6 is negative 18. Negative 3 times negative 2I is plus 6I. Negative I times 6 is minus 6I. Negative I times negative 2I is a positive 2I squared. And as we've seen, I squared is going to change the sign. It's going to make that guy negative 2. So negative 18 and negative 2 is negative 20. These guys right here are opposites and they go away. So we don't have any I left. We just have negative 20. And so our remainder here is 0. And this is perfect. Unfortunately, it makes this middle stuff right here really gross. But we don't get to keep that very long because we know that there is another 0, so we can go ahead and take this guy and we can do a second phase of synthetic division underneath it. We don't need to rewrite anything, we just need to keep on going with the division. And as we've seen before, we know that it's going to be one column less than what we had before. So let's take care of this. We're going to bring down the 3. And for our k value, we're going to be using the conjugate negative 3 plus I. Alright, so let's multiply. Negative 3 plus I times 3, so that's going to give me negative 9 plus 3I. And here's what you're going to find out. We took a lot of time to get this row right here, to do this first part of synthetic division. But once you use the conjugate on this reduced guy, it goes by very, very quickly. See, watch what happens here. You get negative 1, but these guys are opposites, so they go away. That's nice. Now we're going to multiply these, so we get positive 3. Positive I times negative 1 is negative I, and we're left with 2. The i's go away, so we're done with that. Multiply this times the I, or times the k value one more time. That's negative 6 plus 2I, and we see over here that we have a remainder of 0. Alright, so we have 2 of our zeros, we need to find the other 2, and that's what we talk about with this guy right here. So you went from having x to the 4th, this would have been for x to the 3rd, and so here at the end, that's going to be the coefficient for x squared. So let's write this out. 3x squared minus x plus 2 is equal to 0. Alright, so we've got to solve this guy. Now, we could try to factor. You've got 3 times 2 is 6. Are there factors of 6 that add to 1? And the answer is no, so this guy does not factor. You could think about completing the square, but for completing the square, you want this guy to be a 1, and you want this to be even. Now, you can get this to be a 1 for the coefficient, but that's going to create fractions elsewhere, so completing the square is not the best option for us. Which means we're going to go to the method of last resort, which is the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Alright, so let's plug in what we have and see what we get. Alright, so just so that we're all playing the same game, we know that a here is 3, b is negative 1, and c is 2. So negative b makes that a positive 1, plus or minus the square root. So b squared, well, if b is negative 1, you square that, you get positive 1, minus 4ac. You know how we like to do this off to the side. So negative 4 times a, which is 3, times c, 2. So negative 4 times 3 times 2 is negative 24. This is all divided by 2a, so since a is 3, 2 times a is 6. And the rest of this is just a matter of simplifying this expression that we have. So it's 1 plus or minus the square root of negative 23, all divided by 6. And we can finish this just by factoring out the I. When we simplify this, taking that negative, that becomes I in front of the radical. 23, however, is prime, so it stays inside. So here are your other two solutions. So this question was asking us to find all zeros of the function. Alright, so our zeros, we were given negative 3 minus I, but we also know that that's going to include its complex conjugate, negative 3 plus I. And then we did the quadratic formula to come up with the other two zeros, 1 plus or minus I times the square root of 23, all divided by 6. So here are our four zeros. The one that was given to us, its complex conjugate, because we know how complex conjugates work in terms of zeros, and then these last two that we found from the quadratic that was remaining after I did synthetic division. Now we're supposed to find all of the intercepts. Well, what are the x-intercepts? Well, for the x-intercepts, you're going to take any of the zeros that are real, and you're going to convert those into an ordered pair as that real number, comma, 0. Unfortunately, all of these zeros are imaginary. So for the x-intercepts, we have none. This polynomial function does not cross the x-axis whatsoever. But there is a y-intercept. In fact, there's always going to be a y-intercept for a polynomial function because the domain for any polynomial function is all real numbers. And all real numbers has to include 0. And if you can include x equals 0 in your domain, that means you will cross the y-axis. And so for us, come back up here to the original problem. If you plug in 0 for all these x's, then you're going to be left with 20. So that is our y-intercept, 0, comma, 20. So I think the interesting thing here is the fact that there were no x-intercepts because all of these zeros were imaginary. Now, had these guys, had the solutions over here not included the I, had they been real, then you would have just had zeros come, or you just would have had x-intercepts coming from the real zeros. But again, anything that has an I is not going to count for your intercepts, but they do count for your zeros.